Hello everyone, welcome to my YouTube channel. Today we are going to see storage classes in a C language. So as you know, we have already seen some of the constants, how to declare the constants, integer, float, double, how to use it in a C language. Now in case of a variable, we do have a variable declaration that is studied in a previous lectures, but still we are not finished with variables. So to define a variable, we need to mention not only its type but also it's a storage class. So in other words, not only all variables have a data type, but they also have a storage classes. We have not mentioned the storage classes yet, though we have written several programs in a C. So for each C compiler point of view, variable name identifies some physical location within the computer. Maybe that computer memory, the variable is stored in a memory or maybe in a CPU registers. So in case of a variable storage class, it will tell us that variable where it should be stored or it will be stored. Then what will be the initial value of the variable? We have not given the initial value many of the times. We have seen one example in a factorial of number where we initialize the value of f is equal to 1. So this is the second thing that we need to means the storage class will mention what will be the initial value of the variable if the initial value is not specifically assigned, means the default initial value. The third step, what is the scope of the variable? So if we write a variable, what should be the scope of the variable? Means it will be within the functions only, or it has the scope that is a global scope. And the last one, what is the life of the variable? So how long that variable can be used, or how long the variable will exist. So these are the four what we can say a storage classes that will tell us about the variable. Basically in a C language there are four storage classes. First is a automatic storage class, second the register storage class, third is a static storage class, and the fourth is external storage class. All these classes has these four, what we can say, the variable where it is stored, what is the initial value, what is the scope, and what is the life. These four, we can say, the questions that will be tell by all these four storage classes. So the automatic storage class. So what is the storage of the automatic storage class? It is in a memory. What is the default initial value of the automatic storage class? It is unpredictable, means we can say it is called as a garbage value. We cannot predict it, means it's called as unpredictable. What is the scope? Scope of the automatic storage class is local to the block in which the variable is defined. Suppose fact is equal to 1 is defined inside a factor. So what is the scope of that variable? That will be local to the block in which the variable is defined. And what is the life? According to the scope, the life will be, so life will be there of that variable till the control remains within the block in which the variable is defined. So factor is equal to 1. The life of the fact is within the factor functions only. Outside it, it has no life. So this is the four what we can say the automatic storage class: storage, default initial value, scope, and life. If we talk about the register storage class, this is the second. It has only one change. You can see from automatic storage class to register storage class, there is only one change. The storage. Storage is CPU registers in case of a register storage class. While it is same like automatic storage class, default initial value is unpredictable, we can say garbage. Scope of the variable it is defined in a register storage class is local to the block in which the variable is defined, and the life again till the control remains within the block in which the variable is defined. The third, static storage class, it is somewhat different than the automatic and register. Static storage class has a memory location, memory, you can say a storage memory. It has a default initial value. It is initialized as a 0. Scope, local to the block in which the variable is defined as like auto and register. And life, the value of the variable persists between different function call, because the storage is a memory. So we can say that the initial value is also 0. So whenever we are declaring the variable in a static storage class, the value is persist between different functions call. So the life of this particular variable is greater than the automatic and register storage class. And the final, that is called external storage class. It is somewhat different than the other three, as its storage is a memory, default initial value at 0, as like the what we can say static storage class. The scope, global, means if we declare this variable, the variable can be used anywhere, and the life of this variable is as long as the program execution doesn't come to an end. So if we declare something in a external storage class, it will remains there as long as the execution doesn't comes to an end. So this is the way the storage classes in C are. So let us see one by one storage class in an example. So let us see an example of automatic storage class. So for that purpose, what we need to do, we need to write all the program according to the C language. So here I'm going to define it as auto. You can see it becomes a bold, means it is a reserved word. As you know, there are 32 reserved words in a C language. Auto is one of them, means all storage class is one of them. So auto int I comma j. So I'm going to print percentage d comma percentage d I j. Okay, and I'm going to take the function over here. So we'll call a function int function. Again here auto int I comma j. We have to see the scope of it. So percentage d comma percentage d I comma j, semicolon. So here I am going to give the value of j is equal to 1, and here I am going to give the value of j is equal to 2. Control S F11. You can see here 1 comma 139 comma 2. So these are the printed statement. We can write here slash n, control S F11. 1 comma 1 39 comma 2. So these are the values we are getting. So here I initial value j, so it is printed to be as 1 1, and here i's value is different, it is printed to be as 39 comma 2. You can see it again, 39 comma 2. So from this you can see that this particular a has a garbage value. We can say it as a 1, it is printed over here, and this I has a different value, that is 39. Means we can say both this auto main function, in that there is int I, and again same in a function there is int I, it will print in different numbers. So we can say these are the default values of this storage classes. So we can say that we can have it is a garbage value or unpredictable value. It is printed 1 over here, it is printing here, but we can say 39 over here. Second thing, the j, the scope of the j is local to the block in which it is defined. So it is printing here 1, while the scope of the j is here, it is printing. So this is the way the automatic storage class is. So let us look for the register storage class. So we are going to use the same function. We can have register. You can see it becomes a bold register. You can see it becomes a bold, control S F11. You can say 39 comma 1, 39 comma 2. So in this case, the register int I, it becomes a 39. We can say it is a garbage value. It is not 1, it is not 2, it is a garbage value. So we can say the default initial value is garbage value, but it is stored in a CPU register. That's why it comes over here as a 39 again. So that was not in case of a automatic storage class. So it was printing unpredictable value, but it is not printing the unpredictable value. It is printing the garbage value only. So we can say from using register, we are using the CPU register as a storage class. And again, the j is 1 over here, j is 2 over here. So the j is local to the block in which it is defined. And the life till the control remains within the function called as a block. So now we'll go for the next storage class. That storage class is called as a static storage class. So I'm going to change here to a static. Again, static. So you can see here by pressing F11. So default initial value of the static variable is 0. You can see here we have the default initial value. It is as 0, 0. So the storage is a memory again. Scope again local to the block in which they define. I remains 0, j remains 1 in there, and I here j remains 2 in here. So in case of extern, we have to write here extern, external storage class. You can remove the static over here, extern. Okay, so for the declaration we have to declare it as globally int I will have value called suppose 10, j will have value 20 suppose. So int I and j, these are the external variable F11. So you can see here it is printed to be as external 10, 20, 10, 20. So you can see here that it is declared external. So that's why it will take the values from the external, and this value will be persist between different function calls. So you can see for this function as well, the I value is there and j value is there. So if we declare here, suppose I have to declare initially inside it. So by default it becomes automatic storage class by default. This is internal declaration. We can say the local declaration. If we run it, you can see 10, 20 as it was external, and 1, 2 as it was declared internal. So if we just delete it and press F11, you can see the I and j, they are declared globally. So that's why we can say the scope of them are like after the execution ends, we can say life of them as it ends when the execution ends. So I and j, it will persist the value between different function calls. So this is called as a external storage classes. So thank you for listening my lecture.